All right, so today we're going to look at solving quadratics, specifically using factoring. Okay, factoring is something we've done before. That's where we take something that's a quadratic like this and you break it down into the two sets of parentheses. Okay, so we're going to be solving quadratics by factoring. Now, what does that mean, solving a quadratic? Well, solving a quadratic means finding the x-intercepts. So finding the x-intercepts, which is always where y equals 0. Okay, so let's talk about what that means and why we care. Okay, so remember, the point of or the shape of a parabola, it's that U shape, right? That's what quadratic graphs make. So we talked kind of before about how parabolas are something that we use to model things that go up and come back down. Okay, so theoretically, if you had, say, a guy here and he kicks a football, right? And the football goes up in the air and it comes back down and lands. Okay, well, then this would model the path of where that goes. So, what we're finding when we say we're solving a quadratic is we're figuring out, well, where is this point right here? And where is that point? Where did the ball start and where did it land? Okay, because that's going to give us some useful information about this situation. Okay, so when we talk about solving a quadratic, that's what we're finding, is we're finding these 2 points here. Okay, and that means that your y-coordinate has to be 0 because wherever these two spots are, they're on the x-axis. We're talking about where's this ball going to hit the ground, right? Well, the ground has a height of 0, a y-coordinate of 0. So that's what we're looking for. Okay, so there are multiple ways that you can solve a quadratic. This one is specifically factoring. Okay, so how we're going to solve by factoring. First of all, you need to make sure that the equation equals 0. That's the first step. Okay, so you'll notice that here, this equation is already set up equal to 0. Okay, if we had an equation that said y equals something, then we would just replace the y with a 0. Okay, all right, then we're going to factor the quadratic. Once we've done that, we're going to set each factor equal to 0 and then solve. Okay, so let's go through this first example. So I'm going to look at this guy here. And in order to factor this, remember, we're going to break it down into two sets of parentheses. We're going to put the x in the front of each one. I'm going to make a list of all the things that multiply to -5. So that's going to be 1 and -5 or -1 and 5. It's a pretty small list. Okay, and then I need to find the pair of numbers that add to +4. So 1 bucket of water and 5 fires, that's going to be 4 fires. 1 fire and 5 buckets of water, there we go. That's the pair I wanted. So this is going to factor to x minus 1 and x plus 5. Okay, so that's step 1, is you factor it. And then step 2 is we're going to set each one of these factors equal to 0 and solve. Why on earth are we doing that? Okay, well, let's think about it for a second. Okay, think about when you have a really simple equation. Okay, so if I tell you that if you multiply two numbers together, so you multiply some number by some other number and the answer is 0, well, what does that tell us? Well, the only way that you get 0 as an answer when you multiply two numbers is when you multiply by 0. So what this tells me is that it could be that I was multiplying a number by 0, or it could be that I multiplied 0 by a number. That's the only way that I can get 0 as an answer. So what I'm going to do here is I'm going to say, okay, well, now I've broken this down into something times something else. So from here, I can say, well, if these two things multiply and the answer is 0, then that means that either the first thing has to equal 0, so either the x minus 1 has to equal 0, or the second thing has to equal 0. So the x plus 5 equals 0. That's something called the zero product property. And it just says that if you multiply two things together and the answer is 0, then one of the two things has to equal 0. Okay, and now we got two baby equations that are really easy to solve. I'm going to add 1 to both sides over here. So x equals 1. And then I'm going to subtract 5 from over here. So x equals -5. And those are my two answers. Those are the two places where the ball's on the ground, at x equals +1 and at x equals -5. Okay, well, let's take a look at the next one. All right, so this guy right here, we're going to do the same thing. I'm going to start by factoring this. This time the equals 0 is on that side, no big deal. So I know I'm gonna have an x in the front. So I'm gonna make a list of everything that multiplies to positive 2. So that could be 1 and 2, or it could be negative 1 and negative 2. That'll multiply to 2 as well, right? And then we need a pair of those that add to negative 3. Well, that's those guys. So x minus 1 times x minus 2. All right, and now that I've got it factored, I'm going to set each of those factors equal to 0. So either x minus 1 equals 0 or x minus 2 equals 0. Okay, easy solve. I'm going to add 1 to both sides. X equals positive 1. This one, I'm going to add 2 to both sides. X equals positive 2. So those are my two solutions to this quadratic. And again, what does that mean in terms of your graph? Well, it's telling me that this football or whatever it is hit the ground at positive 1 and negative 2. All right, and now this guy down here, now this one's a little bit different because it doesn't equal 0 right now, right? These two both equaled 0. This guy doesn't yet. So the first thing that I'm going to do before I start this problem is I'm going to make it equal 0. To get rid of this guy, so I'm just left with 0, I have to add 9 on both sides of my equation. Then these guys go away, and that's just 0. And over here, I'm going to have the x squared plus 6x plus 9, because none of those are like terms that I could combine together. Great. Okay, so now we've got to factor this. So 2 sets of parentheses, still equals 0. Put the x in the front of each. I need a list of everything that multiplies to 9. So 1 times 9, 3 times 3, negative 1 times negative 9, negative 3 times negative 3. And then I need a pair of numbers that add to 6. So that's these guys. So this is going to be x plus 3 and x plus 3. Okay, and then to finish solving that, I'm going to set each one of these equal to 0 and solve. So x plus 3 equals 0, and over here be x plus 3 equals 0. And you might be thinking to yourself, Miss King, that's the exact same equation. You're right. Okay, so I'm going to go ahead and solve each one of them. But really, you don't need to solve each one of them. If they're the same, you know you're going to get the same answer. So the answer to this one's x equals negative 3. All right, well, you may be thinking to yourself, but Miss King, how does that make sense with my football example? Well, remember that parabolas don't just model footballs. That's kind of the example we've been using. But you could also have a parabola, and what's going on with this guy is that your parabola looks something like this, where it just comes down and it hits at negative 3 and then it bounces back up and keeps going. Okay, so that's kind of what this parabola looks like. So this one doesn't model a football, but maybe it models like the pendulum of a clock. You know, if you've ever seen like a fancy clock, it's got that swinging thing in the middle, right? Maybe this is the path that pendulum's taking. Or like if you think about a swing, this would be like a really, really steep swing, right? But if you think about a swing set, right, it makes that kind of path. So maybe that's what we're modeling, and we're showing where that swing hits the ground. Okay, so there's lots of different uses for parabolas, and that's kind of what would go on there. Okay, so again, solving quadratics using factoring. Okay, and the point of doing this is to find those spots where your parabola hits the ground, hits that y-axis.